Hi, I'm Sarah, and this is Bruce, and we're going to talk about this clock.
I won this clock at auction over the summer. The auction was held to sell off the personal collection of Don and Rita Capehart that they displayed down at their home in Texas. I've been down there twice already to pick up these frames for our panel switch, and I'd passed by the clock on the wall a number of times, but it never quite caught my attention. It's probably because Don's collection's huge, and probably because I only had eyes for the panel frames that I just basically ignored it. But when it came time for auction, I took a closer look, and I started to suspect that it wasn't just any ordinary clock. The auction didn't have any pictures of the inside, and the description was vague and ultimately inaccurate. But while I was looking at it, I noticed that it might have something special about it, so I bid on it and won. When the clock arrived, it was not in running condition. Most of the parts were there, but the pendulum suspension spring was broken, and the going train and motion work were heavily encrusted with grease, and the clock was also badly packed, so the glass was broken and had to be replaced. Luckily, the pendulum was wrapped up, so it didn't completely destroy the movement. I took the clock apart and repaired it as best I could, and I'm happy to say that it's keeping time quite well. The clock itself is made by the Self-Winding Clock Company. SWCC was a major supplier of clock systems through the late 19th up to the mid-20th century, and these systems usually involved a master clock that controlled several secondary clocks throughout a building. Some of you might recognize these from school, where all the bells to switch classes would ring at the same time, and the classroom clocks were all synchronized to a master clock somewhere in the principal's office. SWCC also made many fancy clocks, including the one atop the information kiosk at Grand Central in New York City. The Self-Winding Clock Company was not the only provider of clock systems like these, but since that's who made this clock, this is what we'll be focusing on for this video. Like the name says, the clocks were self-winding and self-synchronizing. The benefit of this was that you didn't have to have a worker going around to wind and set the clocks all the time. They'll run unattended for extended periods, always showing the correct time. In order to provide the synchronizing feature, SWCC teamed up with Western Union in 1889. At the time, Western Union owned the largest telegraph network in the world, and SWCC knew that their telegraph lines could be used to transmit synchronizing pulses to their customers' clocks around the U.S. The synchronizing pulses originated at the U.S. Naval Observatory and were sent at noon each day. Each customer of the Western Union Time Service had a master clock somewhere in their facility. The master was a very high-quality clock with a very accurate movement. This clock was set daily and was used as a local reference for all of the secondary clocks. This clock is one of those secondaries, although, as you'll see, this is also sort of a master in its own way. During the 20th century, Western Union supplied clock service to a whole ton of companies, including AT&T and their subsidiaries. In most telephone company deployments, the master clock was located in the main central office downtown, and the branch offices had a synchronizing feed from there. So the main office was synchronized directly from Western Union, and then hourly synchronizing pulses were sent out from the main offices to the clocks in the other COs around town. I looked through some photos we had to see if I could find the master clock in the telephone building in downtown Seattle, but sadly, I couldn't find it in any of the pictures we have. I did, however, find clocks like this one everywhere in the building. They're an older style, but the movement inside is exactly the same. Okay, now that we know a little bit about what this clock was used for, let's take a look inside. This clock is from the 1930s, but the insides are very similar regardless of the clock's age. This is known as the F movement, and it was the standard for most of the 20th century. There were also several types preceding the F, but this one seemed to be the one that was produced in the highest quantity. The power to drive this clock comes from a mainspring that's automatically wound once per hour. The timing and duration of the winding is controlled by a cam known as a sector that revolves around with the minute hand. When the sector cam reaches the top of its rotation, it closes contacts that cause the winding to start. When the mainspring has been sufficiently wound, the sector cam is pushed forwards, which breaks the contacts that control the winding motor.
So it's getting smaller and smaller.
The winding motor itself is really just a self-interrupting relay. That is, when the relay energizes and the armature is pulled upwards, it breaks the relay's own operating path, which then causes the armature to release. This remakes the operating path for the relay, which causes the armature to be pulled upward once again. And this rapid make and break of the relay's operating path causes the armature to oscillate back and forth rapidly. As the armature oscillates, it operates a ratcheting mechanism that winds up the mainspring. The power for the winding relay comes from the central office 24-volt battery supply. Normally, these clocks ran on 3 volts and were powered by a couple of dry cell batteries. But for telephone use, they were modified to use 24 volts because 24-volt power was available in every telephone office straight from the main battery feed. So it was easy and convenient to use. Now, I could power this clock from the museum's battery supply, but I want it to run even when the museum is off. So I'm cheating and using a modern 24-volt power supply that I got from a local electronics recycler. This way, the clock will go on winding itself every hour, whether or not anybody is here to turn the museum power on. The hourly synchronization is handled by this relay in the upper right. Each hour, on the hour, a pulse is sent out by the master clock. The pulse operates this relay, and when it does, this arm comes down and unceremoniously slams the hands into the on the hour position. I tried to get a better shot of this, but I got really scared when the synchronizer engaged, and I jumped even though I was waiting for this exact thing to happen. Fortunately, a clock expert on YouTube was able to capture this process in much more detail. His channel is linked below, and I highly recommend checking it out if you want to learn more about self-winding clocks. Now, we don't have a master clock to send synchronizing pulses every hour. So instead, I wrote a small program for an ESP8266 that does the same thing. It gets the time from NTP, and each hour it closes 24 volts to operate the synchronizing magnet. It's working out really well, and I'm super happy with it. Someday, I'd love to get an actual master clock, but they tend to be so expensive that it's out of reach of what I can reasonably afford, especially given my other heavy and expensive hobbies. So what makes this clock special? Well, since it was a part of a telephone auction, I suspected that it came out of a telephone central office, and if it did, it likely had a special option that wouldn't have been included otherwise. And this is it. The 6-second contacts. As you might expect from the name, these contacts close once every 6 seconds. The timing is controlled by a small gear that is driven by the rest of the going train of the clock. The 6-second contacts were used to control the 1A secondary clocks at the various desks around the office. These clocks are very basic. They're just counters, really. They measure time in hours, minutes, and tenths of minutes, and require 1 pulse every 6 seconds. The one here in the panel office was not installed when I first arrived at the museum 6 years ago. At some point, though, I pulled the key shelf on this desk apart and found a hole where the clock was originally supposed to be. Wanting to keep things as original as possible, I installed the correct clock there. But I didn't have a way of driving it at the correct intervals using equipment that we had in the museum. This new wall clock solves that exact problem, and it's why I was so excited to get it. We have several 1A clocks in the museum, and it wasn't practical to wire each of them to the master clock itself. Instead, I'm using this master clock to drive a relay that I've mounted on the panel switch. That relay actually operates all of the clocks throughout the museum. I can add more relays if I need to, and thus I can drive as many of the secondary desk clocks as necessary. Below this clock is a large wooden box. This is a battery box, and it's much older than the clock itself. I don't have a lot of solid info on the battery box, so the following is just my best guess based on what I already know about the telephone history and how they did things. The box predates the clock because this clock was probably swapped out for a newer model and the original battery box was retained. The box is way too large to contain just dry cell batteries, so it likely contained glass jar batteries like Leclanche cells. The thing I don't know is why this battery box was necessary if the central office almost certainly had 24-volt power available. Either the batteries were used as a backup, or the clock ran on its own power independent from the central office. Neither of these two scenarios makes total sense to me, but since I haven't found any solid information, a guess is the best I can do. Anyway, I'm super happy to have this clock on the wall here. Big thanks to our volunteer Eric for doing most of the hard work of actually mounting it. We put it on this wooden box to bring the clock far enough out from the wall that it could be seen clearly when viewed from ground level, even with the battery box sticking out below it. Also, big thanks to kensclockclinic.com for hosting manuals and other historic documents regarding self-winding clocks. And if you want to know more about these clocks, be sure to check out this YouTube channel. His videos really helped me when it came to restoring this clock. We've got a lot of really neat projects coming up, including installing a real city ringing plant, the 3 ESS, and coin service, and our number 5 crossbar. So stay tuned for those. See ya!